All right, folks, this is going to be a quick tutorial on how to turn assignments in on Google Classroom. So here's Google Classroom. I signed up for period 2 biology. So I'm going to go ahead and click on that. Okay, here's our cohesion adhesion lab. I'm going to click on that. All right, here's the document right here. So I'm going to click on this document. All right, so right now it won't let me type on it. So I'm going to go up here and click Open with Google Docs. All right, so now once it opens in a Google Doc, I'll be able to type on it. All right, so now it's a Google Doc, and now I can type on it. I don't need to put my name on it because it already has your name up on the top. All right, so which liquid required the most drops before it fell off the penny? Well, that was the regular water. It required the most drops. It was like 30-something. It varied from class to class. Why do you think this liquid required the more drops? So why did regular water hold more drops on a penny than soapy water? Well, that's because regular water had stronger hydrogen bonds holding the molecules together. All right, so the regular water had stronger hydrogen bonds, where the soap actually interferes with those hydrogen bonds and doesn't allow the water to hold on to each other quite as strong. Can you think of any sources of error in this experiment? Well, if you remember, one time the heads side was up and the other time the tails side was up. Well, remember, that's a controlled variable. So if you have the head side up for the regular water, you got to have the head side up for the soapy water. You can't flip it around because one side of the coin may just hold more liquid than the other side. And also the size of the drops weren't the same. So it didn't seem like the size of the drops were exactly the same. All right, so now the paper station is where I put drops of water on regular paper. Some classes I used a microscope slide, a glass, and then I put drops of water on wax paper. Well, what happened when I turned them over? Well, the regular paper and the glass, the drop didn't fall off. With the wax paper, the water drop fell off. All right, so that's not the greatest English ever, but with the glass and the regular paper, the water stuck to it. So I flipped it over, but the drop didn't fall off. But on the wax paper, it immediately fell off. Why do you think this occurred? Well, paper and glass are polar. They're polar just like water. So since they're polar, that means they have a part of their molecules that's positively charged and the other part that's negatively charged. Well, just like water has the same thing, so the positive and the negatives are attracted to each other and they stick together, they bond together. Why did the water droplets appear to stick to the glass dropper? So this when I was playing Agar.io and I was dragging the drop around and eating the other drops. Well, water sticks to glass because, like I said a second ago, glass is polar. Glass is polar, so the water is attracted to the glass. Did this activity demonstrate cohesion, adhesion, or both? We're just going to put both because when the water was stuck together in a big glob of water, that's cohesion. And when that drop of water was attracted to the glass, that's adhesion. All right, cup station is where I poked 10 holes in the bottom of a cup. We didn't do a hypothesis, we forgot. But what happened when the water was poured into the cup with holes in it? Well, when that happened, the water stayed in the cup. So the water did not go through the little holes in the plastic cup. Why do you think this happened? Well, water was bonded together with hydrogen bonds. So all those little water molecules were all stuck together. And so that's why it did not go through the tiny holes because they were all stuck, bonded together with hydrogen bonds. Now what happened to the alcohol? The alcohol went through the holes. All right, so the alcohol did go through the holes, even though it looks just like water. It's actually the molecules are larger than water molecules. So why did it go through the hole? Why did it go through the holes and the water didn't? Well, water is more polar. than alcohol. And since water is more polar, its hydrogen bonds are stronger and doesn't allow the water to go through the holes. All right, so now we're back on Google Classroom, period 2, Cohesion Adhesion Lab. The first thing I need to do is hit Add or Create. So I'm gonna click on this, and every time I type a Google Doc, it always gets saved in my Google Drive. So I'm gonna click on that. And that should show me my document I just typed on. I got 2 of them in here. This is the most recent one I typed on, so I'm gonna click on that. I'm gonna hit Insert. Now you can see it's getting uploaded right here. Boom. And once it's done uploading, simply click Turn in, and voila. That is how you turn in assignments using